In order to create and develop software, we need to have a process. That process is known as software development. This takes our initial ideas of a software concept and moves it all the way to a finished version, fully completed and fully coded software. These software applications and programs that we create through software development can do a wide variety of different tasks, but that's not what we're focused on. In this section, we're focused on understanding how software development is actually done. And in this video, more specifically, we're going to learn about how the process of software development occurs and the different types of programming languages. So let's dive into programming languages a little bit here. Programming languages are the various languages that we use as humans to write instructions to tell our devices what exactly to do. So no matter what the function of a software is, it's written in some sort of code or some sort of language that the computer or device can actually process to do some sort of task. Next is scripting languages. So scripting languages are a subcategory of programming languages. Many people think that programming languages and scripting languages are two separate things. But in reality, programming languages are at the top of the pyramid. Meanwhile, scripting languages sit as a subcategory below them. Our scripting languages are there usually to help us automate tasks and help with quick tasks. Usually scripting languages are a bit easier to work with and to learn and to actually implement. Here we're going to be covering these topics in this video. We're going to be talking about the basics of software development, general purpose and specialized software and languages, assembly languages, query languages such as SQL, how we actually design software, compiled and interpreted languages, scripting languages, and lastly, markup languages like HTML, XML, and CSS. Let's dive right into the basics of software development. So software development involves, again, creating software from the very start to the very finish. It includes activities along the way, like writing code, organizing how a program works, testing code, and fixing problems, and patching things and updating things as they come up, and also interaction with our users, our customers, or our employees who are going to be using the code. One of the main things that people neglect when they're actually writing software or writing code is who is going to be using it. The practice of software development also includes having users help us understand their needs and us ensuring that we're meeting those needs. So here's some main building blocks of software development. First is data types. These explain how different kinds of data, such as numbers, text, values, are stored and used in different programs. There's also programming concepts. So this is introducing the basics of programming, such as variables, loops, and conditions. Lastly, we have organizing code in our logical flow. This focuses on arranging our code in a clear and logical order and way of operating so that our programs run efficiently and correctly. Next up is actually designing our software. So this is planning how our programs, applications, or software will work, what features and structures and user interfaces it will have. And usually the software designing process, like I mentioned earlier, will include some sort of customer or user interaction as well to ensure that we're meeting their needs. This whole process of designing is done before any code is actually written or before the whole process of building out code or writing it is actually performed. So here's what designing software helps us do. It defines what software will actually do and how users intend to interact with it. It also helps plan the structure and the workflow of the program before we actually code. So it provides us a structure, a way of understanding the bigger picture and how things should flow. Designing software is important because it helps us prevent errors and it also reduces our development time. Because designing software focuses on making sure that everyone involved, the software developers, the project managers, the customers, or the users are all aligned, it helps reduce development time and rework. It also ensures that software is easy to use, that it's efficient, and ideally that it's relatively easy to maintain. Next are the language categories that we're going to be exploring. We're going to be exploring these 5 categories for the Tech Plus exam. First, we're going to explore compiled languages. Then we're going to explore interpreted languages. From there, we'll explore scripting, query, and markup languages as well. Before we dive into those 5 software categories, let's go into general purpose and specialized languages. So our general purpose languages are designed to be used for a wide variety of tasks. Meanwhile, our special purpose languages are designed for more specific tasks, such as web development, data science, or machine learning. Let's talk about general purpose first. So general purpose, it's used for many different types of use cases, programs, and software. It's very flexible. It's used for many software apps, games, and many different types of use cases. And the skill level to actually implement general purpose software is usually relatively low, but it is used by both beginners and professionals. Next is specialized software. So this is designed for very specific tasks or fields. It's also limited to certain functions, mainly used in things like web design, data analytics, automation, and systems. The skill level for specialized software and these different types of software or specialized languages rather, they're mainly used for very specific roles, and they do usually require a little bit more of experience to actually code in them, to use them, to compile them, and to implement them in general. So let's go into the first of the 5 language types, compiled and interpreted languages. So these programming languages can be grouped by how their code is actually ran. The 2 main types here are compiled and interpreted languages. Let's first go into compiled here. So compiled code translates the entire code into machine language before it's ran. Speed here, compiled runs faster. Error handling, errors are shown after compilation, so it's not during execution, it's actually after everything's been ran. Some examples of compiled languages include C and C++. Interpreted languages translate and run code line by line. Usually they're slower than compiled languages, but errors are shown immediately because code is ran line by line by line. We actually get errors as it's being ran. So usually we see errors a lot faster. Next, with examples, some examples of interpreted languages include Python as well as JavaScript or JS. Our third language type here is scripting languages, and these are usually used to automate tasks, control software or systems, and they're normally interpreted and ran line by line. Some examples of scripting languages are JavaScript, Python, PHP, and PowerShell. Both JavaScript and PHP are commonly used or very used in web design, and Python and PowerShell have much wider use cases at the system level. Scripting languages usually automate repetitive tasks, control software, add some sort of functionality. So JavaScript is a very good use case for functionality for websites. They also make tasks faster and easier to perform sometimes, and they also are usually easier to write in and edit than full-blown programs. Again, commonly used in web development are JavaScript and PHP in system administration, PowerShell, and Python. Python has many, many different use cases though, but Python is by far the most flexible and has the most use cases out of all of these. But again, JavaScript, PHP, web development, PowerShell, system administration, and Python has many different use cases, but it can help with system administration as well. Next up is markup languages. HTML and XML are 2 common ones. Markup languages are mainly used in website design. So the actual what we see on website pages, that's built in HTML and XML. They're also used for organizing information. Now, one thing here, HTML and XML are 2 popular examples for the exam, but CSS is another example of a markup language in addition to HTML and XML. 2 most common markup languages are HTML and XML here. So HTML is hypertext markup language, and this focuses on structuring and displaying content on web pages and actually building out the visual side of things that people see. It's used to build website structure and layout. It focuses on how content actually looks in a web browser, and it's essential for building websites and web pages. HTML nowadays is still crucial. One thing I wanted to note here, even if you use a web page builder, something like WordPress, something like a drag and drop web designer or web page designer, on the back end, it's still using HTML, CSS, and XML. So just keep in mind, HTML, while you might not be necessarily seeing HTML code nowadays as much on the back end, even if you're using WordPress or something else, even Shopify, it's using HTML. So just keep that in mind. You don't need to really know that for the exam, but just understand for real life use cases, HTML is still primarily what's being used on the back end, even if you don't see the actual code. XML here is extensible markup language. This is more used for storing and transporting data. It organizes and shares data as well, focuses a lot on data and really just sharing data in general. So here we have query languages and SQL as the 4th language type. So query languages are used to request and retrieve information, usually from a database. The most common query language is structured query language, or SQL. SQL is used to allow users to retrieve, add, update, delete data in a database, used to organize and manage large amounts of information. And it can also help certain applications communicate with databases to actually modify information in databases or to be connected to them. SQL is important because it makes working with large data sets rather easy and rather quick. It's also used on the back end of websites, applications, and various business systems, again, for data management, reporting, as well as data analysis. The last language we're going to learn here is assembly language. Assembly language is the lowest level of code in which we as people can actually write. It allows us as developers to give instructions straight to our hardware. Assembly languages, essentially, they allow us to control hardware used for tasks that require high performance or direct hardware access, and usually we use these in mainly operating systems, device drivers, and different types of embedded systems. So that covers the basics of software development, as well as some of the basic programming languages. In the next video, we're going to go into some of the important programming concepts and best practices that programmers use in order to build the best software.